In this video, we are going to do these three questions. Well, this figure is actually a part of this question from the chapter Areas Related to Circle, class 10th. And that uses the formula for area of a circle, including the area of a quadrant, right, as in case of this area of a quadrant, and the concept of percentage and ratio. So let's begin with the first one. In this question from the chapter surface area volume, it says a sphere of maximum volume is cut out from a solid hemisphere of radius 6 centimeter, and what we have to find out is the volume of the cut out sphere. So what I'm going to do is to first make a sphere, I'm going to make a hemisphere first. I'll convert this into hemisphere. Now these portions has to be trimmed so we can get a hemisphere over here. Now this is what? A hemisphere. Now this is what the upper part of the hemisphere. Now I'm going to accommodate a sphere, and I check here that which should be the one which has the maximum volume, right? This is the maximum volume. Now check here, from here to here is what? The radius, which is 6 centimeter for the sphere, and you should figure out that this is also 6, right? So we can say that whatever is the radius for this, say capital R if I use, is the radius of this hemisphere is actually the diameter of the sphere, and the diameter of this sphere I can say 6 centimeter. So we can say therefore the radius of this sphere is 3 centimeter. So once you know the radius, you can find its volume by applying the formula. And what is the formula for finding the volume of a sphere? It is 4 over 3 pi r cube. Pi, and the r is small r. So replacing the pi with 22 over 7, the radius, as we can see, it's 3 into 3, that multiplied by 3. So these three get cancelled over here. The value of pi is not mentioned, so this is 88 and this is 9 over 7. So we'll multiply 88 with 9. So 88 into 9, that means 7 into 9, 72, 72, 9, 8 divided by 7 centimeter cube should be the volume of this sphere. In this question from the chapter Areas Related to Circle, it says sum of the areas of two circles which touch each other externally is how much? 153. So first let's make two circles and then we will read it further. I made one circle, say this is one circle, and then another circle, and these circles are touching externally, right? Now further, their area is given, so I should draw their radii, like this being the radii. I mean capital R I indicate as the bigger one and small r as the small is the for the small circle. And we are given the sum of the areas of these two circles. That means pi capital R square plus pi small r square is given as how much? 153 pi. That's the first information. Now if I read it further, what does it say is that if the sum of their radii is how much? 15. Right. So we also know that the sum of the radii, that means say capital R plus small r is given as how much? 15. Now it's very clear that there's a square relation and we'll be using quadratic over here. So, but before that, I can see it can be simplified further by taking pi as common from the left hand side. You can figure out that this pi get cancelled. Right. So as a result, what we got here as this, that is capital R square plus small r square is equal to 153. Now here I'm going to do substitution in the next step. I'm going to replace this. First of all, I can obtain capital R should be how much? It should be 15 minus small r. Now check this one, I marked this as 1 and this as 2, and I'm going to replace this capital R, right? This capital R I'm going to replace with the value we just obtained as 15 minus R. So for doing substituting this, let's say if I substitute over here, so we have capital R square. Let me once again write down capital R square plus small r square is 153. Replacing capital R with how much? 15 minus R whole square plus small r square as it is equal to 153. I will apply a minus b whole square identity. So a square, which is 225, minus 2 times a into b, that is minus 30r, plus b square as r square, plus r square is equal to 153. Now check, we have r square plus r square. That means I can write 2r square minus 30 times r. And if I keep these on the, if I bring this on the left hand side, it should be subtracted. So 5 minus 3 is 2, and then this is 12 minus 5 is what? 7. Yeah, that's what is equal to 0. Now I can reduce it further by taking 2 common so as to frame a quadratic. This is what we got after taking 2 common. Now we will be using middle term factorization to solve this. So for factorization, from the factors of 36, what we need? 15. So that is what? 9, uh, yeah, 12 into 3, right? 12 into 3, that's what we'll do. So this is r square minus 12r minus 3r plus 36 equals 0. So taking r as common, we'll get r minus 12. Taking minus 3 as common, we'll get again r minus 12 equals 0. So this is r minus 12, and this is r minus 3 equals 0. So you can see that equating this with 0, I'll get r as 12, and equating this with 0, r as 3. Right. Now check what was we had to find out is the ratio. So we can see that if I take uh, the bigger small r, right, as you can see that I have denoted the capital R as this, the bigger one. So the small r will come as 15 minus 3. So that is 12. And the ratio is what? The larger to the smaller. That means the ratio so obtained has to be from the bigger to the smaller. So the bigger one is capital R, smaller one is small r. So that is 12 over the small r is 3. On reducing, it's 4 over 1. So the required ratio is 4 is to 1. Okay, so we have an option here, that is A is the correct option. Now in this question from the chapter areas related to circle, it says in the figure, 2 circular flower beds have been shown on the 2 sides of a square lawn. Well, this is a square lawn, and flower beds are drawn. So clearly these are the flower beds over here. All right. And the figure is named as ABCD, whose side is the square, the side of the square is 56. If the center of each of the circular flower beds is the point of intersection of the diagonal, so O is the point of intersection of the diagonals of this square. Now, what we have to find out is the sum of the areas of the lawn and the flower bed. So this is the lawn, right? This is the lawn over here. The one I just painted, that is a square. And the flower bed are what? These are the flower beds. This is the flower bed, and this also is a flower bed. So we have to find the combined area of this. So we are not supposed to find their individual area. Now, the first thing that we will be applying here is the property that diagonals of parallelogram bisect each other. Now you can figure out that this is can be said as the radius of this sector. Look into this part. I'm talking about this portion only. This is what? This is a quadrant, or you may say it's a sector whose central angle is how much? Central angle is 90 degree. So these are 90 degrees. So we can say these I can take as R also. Now to apply this property, I'm just considering this triangle. Look into the triangle I'm talking about, this triangle. Check here, it's a right angle triangle, right? It's a right angle triangle. As you know, the diagonals of square and a rhombus bisect each other at 90 degree. So what you can see from the figure, that is r square plus r square is equal to 56 square. So that means 2 times r square is 56 into 56. And if I get r square only, it should be what, 56 into 56, that divided by 2, right? So on reducing, I'm getting this as 28. So let's keep it like this only, because it's related to area and we may need r square only. We will figure out whether we need r or not later in the question. So now once we got the radius over here, well, the purpose of getting the radius was to get the area of this quadrant, right? So now once we got this radius over here, now we are going to find out the area of this figure. So area of this quadrant is what I'll go for first. For finding the area of this quadrant, well, these and these are same, right? These and these are same. So we can just multiply. These are symmetrical figures with equal areas. So for finding the area of this quadrant, it should be what? Area of a quadrant is what? 1 over 4 pi r square. So let's say if I use a dash over here as 1 over 4, but then we have 2 times such an area. So I know I should multiply 2 in the beginning only. So 2y, because there is a 2 quadrant, and 1 by 4 pi is not given. So we are going to apply pi as 22 over 7. So pi, which is 22 over 7, that multiplied by r square, and r square is how much? 56 into 28. Right. So 7 into 4 is how much? 28, and 28 get cancelled. Now we can now say that the area over here should be product of these numbers. So that is 56 multiplied by 44. That should give you 2464 centimeter square. Now we also have to find out the whole area. For that, now there is a right angle triangle, this, and this is a right angle triangle. So for a right angle triangle, right, these are considered as its base and altitude, right? I can take this as the base and this as the altitude. And why so? Because this angle is 90 degree over here, right? So for finding the area of a square, triangle, right? And what's the formula for finding the area of a triangle? It is half base into height. So we are going to apply this formula, that is area of a triangle, which is half base into height. So I'm going to take the area over here. So this is, I'll use a dash for area. Now check here, there are two such triangles. So I'll be multiplying 2 first. And area of a triangle is what? Half into base into height, or the altitude. So a double dash over here, you can see that 2 and 2 get cancelled. And as for the figure, base and radius, base is r and the height is also r. So that is 8 r square only. And we have the value of r square. That is 56 multiplied by 28. So this is how much? This is 56 square, 28 square, right? So 28 square is 748. That multiplied by 2. So it should give you 1568 centimeter square. So we got the area of this two triangles. As you know that we have to find the combined area of these two. So clearly the final area, say A, will be A dash plus A double dash. So adding these two numbers, that is 2464 plus 1568. So if I add this number, that is 2464, right, with 1568, I'll get this area, and the total area will come as how much? 4032 centimeter square. That's how we got the sum of the areas of the lawn as well as the flower bed. There are alternate ways by which you can do, but I find this easier. In this MCQ from the chapter areas related to circle, it says that if the radius of a circle is diminished, that is reduced by 10%, And then what we have to find out, the area of this circle will be diminished or reduced by how much. So let's say, for example, if I take r dash as the new radius, should be how much? After reducing it by 10%, it will be 90%, right? 90% of the original radius, say capital R. So what I can do, 90% is what? 90 over 100 times R. So I can cut these zeros. That way I can get, and writing in them ratio, well, I suggest whether it's a ratio or percentage, obtain the ratio. That's way it is easier. Now, once we have got the radius, now we have to find what? The ratio of their area. So let's say the new area is A and the original area is A. The new area is what? Pi r dash square, and the original area is what? Pi r square. Here too I can see that pi and pi get cancelled. So that results to give you A dash over A as how much? Square of this, right? This is R dash over R whole square. So that is 81 over 100. But then we have to find out the percentage. We got the ratio as of now. So to convert into percentage, we'll be multiplying by 100 and putting a percentage sign. So here these 100 get cancelled. So from here we get the new area, say A dash is how much? 81% of the original area on transposing this A to the other side. So now think about it. Let me write down properly. What I'm saying over here, the new area, A dash is what? 81% of the original area A, right? So if the new area is 81%, the original area, how much percent it is reduced? Has to be 100 minus 81, that is 19%. So it is reduced by 19%. Yes, this is option B is correct in this case.